Alright, in this video I'm going to be talking a little bit about graphs and any transformations of logarithmic functions. So I'm going to look at two examples. This first example says f of x equals log of x minus 3 plus 2. So if I wanted to graph this, I know that anytime there's a log without a little base right here, it's a log base 10. It's what we call the common log. And anytime my base is greater than 1, I know that this is logarithmic growth. So my parent function right here is our logarithmic growth function, which has an asymptote at x equals 0 and an intercept at the point 1, 0, and starts along this asymptote, goes through this intercept, and then increases slowly as you see in that picture. Okay, so that's our original function. But I've got some transformations here. I know that we've got this minus 3 on the inside of our log, which is going to shift us to the right 3. And I've got this plus 2 on the outside, which is going to shift us up 2. So if I want to take my original point and my asymptote, I'm going to shift them right 3 and then up 2. And my resulting graph will be a picture of my logarithmic function log of x minus 3 plus 2. So I'm starting at my normal point 1. I'm going to shift it right 3. 1, 2, 3. And then I'm going to shift it up 2. 1, 2. And my new point is going to be right here. And then if I have my asymptote's right here at x equals 0. So I'm going to shift that right 3. 1, 2, 3. And it's going to be at positive 3. And if I think about shifting it up 2, it's going to continue to go all the way up and all the way down, so it won't look much different, but it's going to be along this line x equals 3. Okay, so I've got my function approaching from my asymptote, going through this point, and then increasing slowly like you see there. So here's a sketch of my new function. If it asks for the domain, range, and asymptote, let's go ahead and write that down. My domain is now going to change from being from 0 to infinity to being at my new asymptote 3 all the way to infinity. My range, my y values, my graph will go all the way down from negative infinity, and it increases without bound heading up to positive infinity. And lastly, my asymptote is no longer over here at 0 because we moved right 3. It's now at x equals 3. And I could ask about a lot of different things, the end behavior, all sorts of stuff, but if it asks for the domain, range, and asymptote, that's what you'd be looking at. Okay, second example. F of x equals negative ln of x plus 3. So I've got a little base of e right here. So if I'm thinking about doing this transformation and this transformation, the graph I'm starting with again, just ln of x would be like this. Logarithmic growth would be normal ln of x. If I have a negative on the outside, that's going to reflect it over the x-axis. Interesting, so we'll see what that looks like. And then a plus 3 on the inside is going to shift it left 3. Okay, so let's take our point and our asymptote, shift them left 3, and then reflect this graph across the x-axis. So if I'm starting at 1, where my point usually starts, 1, 0, and I shift left 3, 1, 2, 3, I'd be over here at negative 2. And if I take my axis, which starts at 0, and I shift it left 3, 1, 2, 3, I'd be over here, 1, 2, 3, at negative 3. So my function is going to start at this asymptote, go through this point, and then increase gradually like that. Okay, so now I've got this picture, but I've got to reflect it over the x-axis. So before actually I make this permanent, let's think about what would happen if I have, I'll make it a little bit lighter from racing, if I have this graph right here, but I reflect it across the x-axis. It would look something like this, where this part that was coming from the asymptote right here from negative infinity would be coming from positive infinity, and this piece would be now below the axis like this. So this is what my final graph would look more like. For my domain, even though it's decreasing now, is still going to go from this asymptote to infinity, so from -3 to infinity. And my range is still going all the way down to -infinity and all the way up to positive infinity. And finally, my asymptote, as it asked for in this example, is over here now at x equals -3.